All right, we're going to take a look at them now. But before we take a look at them, I want you to tell me what you think they're going to look like.
Well, I mean, if you have, here, bring this back.
Yeah.
So it's not going to include any points with a 1 and a 0 in it.
Ah, okay. It won't include any points with a 1 and a 0. Very good.
It can't include any of the corners.
Except for 1, 1, 1.
And 0, 0, 0.
No, 0, 0, 0.
Ah, okay. So that's interesting. Except for 0, 0, 0 and 1, 1, 1, none of the other corners are part of this shape.
And
Good
then
observation.
Actually, it can't include anything where the maximum is greater than 2/3, and then the minimum is 0.
Ah, okay. All right. What do you think?
Well, so I think it's going to have these corners, and then it's going to have part of these sides going out until it reaches a point where it no longer satisfies the conditions.
Yeah.
And then they might sort of, I don't know, come together at the center.
Okay. Well, here they are. Here's the one shape. Can you look through the camera? And should we move this to the table to make it show up better? Okay. Here, take the board away. All right. So here they are. So here's the shape, and here's the complement. All right. So tell me what you see on these. I'm going to zoom in just a little.
Well, this one sort of reminds me of a rhombic dodecahedron.
Ah. Okay. Ooh,
It does, except like there's like sort of this corner of the square here.
And actually, it also reminds me of our hypercube B, where you took a cube right here.
Yeah, make sure you're still on the screen, by the way.
So you can see this small cube here,
Yeah.
and then sliding it down to here.
Oh, very, very nice.
Seems to be like you pull the cube. You're like pulling the cube.
Yeah.
And you have this part here and this part here, and then you have
try to stay in the middle here. While you guys are talking, I'm going to go get Hypercube B because I happen to know exactly where it is.
So you have this face here, and this face here. It makes up one part, and then the other 3 faces of the cube that makes up the other part, and you sort of pull them apart, and you get the stuff in the middle.
All right, there's Hypercube B, by the way.
So in Hypercube,
stay in the middle.
In Hypercube B, like the cubes are a little smushed. But in this shape, I guess, the cubes actually look like cubes.
Okay, cool. So actually, that's neat that this shape sort of reminds you of something we've seen that was 4-dimensional. Okay. What about the complement? What do you have to say about that?
Well, you can see where the shape was sort of cut out.
Yep.
It has the rest of the corners.
Yeah, unfortunately I printed them to be exactly the same size. I didn't think ahead, so it doesn't quite fit through. I definitely want to do that, but I would have needed to have printed this just slightly bigger because they're literally exactly the same size. So, bad luck. But it would fit through, and when you look at it when it's coming through, what do you see? Am I on camera, Bill?
Yeah.
What do you see there?
So you see, I mean, it's kind of like the miniature cube faces.
Yeah.
There.
Yeah. Okay. Anything else you want to say about the shapes?
I mean, they sort of looked like as sort of I envisioned it. Like, so if you look, you can sort of see, this isn't how it goes together, but the corner, and then it went along the face until a point where your thing didn't work. The condition didn't work anymore. And then it did the same thing around the origin down here.
Right.
And then they sort of came together.
Okay. Do you see any symmetry in these shapes?
I see a lot of symmetry.
Okay. Keep it in the middle.
Well, I mean, if you tilt this up, you see 3-fold symmetry.
Oh, where?
So in the center, you cut along these edges.
Okay, so that's interesting. There's 3-fold symmetry.
And I think this shape also has threefold symmetry if
Yeah,
you
it
hold it
does.
like that.
Okay. Cool.
I
So-
think it has twofold symmetry too along this line.
Oh, interesting. So that would mean if it has part some ways 3 and some ways 2, how much? How much?
It should have sixfold symmetry.
It should have some. Well, maybe not sixfold, but we see when we have the original numbers x, y, and z. How many different ways can we permute those?
Well, 6 different ways.
6 different ways.
So maybe that is something
So,
to do with this.
in other words, if we find a solution a, b, x, y, z that's in here, the 6 permutations of it should be in there.
Yeah. Pretty cool.
Yeah, it's pretty cool. So now what we're going to do to help us find the volume, we got to find the volume of this, which we can do in 2 different ways. We can find the volume of this directly, or what?
Find the volume of this.
Find the volume of this. Which one do you think is easier to find the volume of, actually?
Seems like this one.
That one?
Well, I mean, I think this one might actually be easier.
Okay. Well, we're going to build them both out of zone.
Alright.
And then we'll talk about the 2 shapes, okay?
Alright.
Alright.